Hello viewers, this is Form 2 Mathematics from the topic Angle Property of a Circle, and we want to look at how you calculate angle VWY, this angle here. So how will you calculate this angle? As you can see here, we've been given only two angles. This angle will be given to be 110. This is angle VUZ. We've been given this angle to be 110, and we've also been given this angle XVY to be 30 degrees. So how will we calculate this angle? We'll start by first calculating the angles that are missing. The angles that we know we can calculate with ease, that will lead us towards calculating the angle that we don't have. So let's start from here. As I told you previously that when you have given such questions, you must take your time first to study the diagram that you've been given, so that you can know all the angle properties. You try to figure out all the angle properties that have been applied that will enable you to calculate the angles that are missing. So like here, when you look at here, this one, this quadrilateral YVUZ, this is a cyclic quadrilateral, and we've been given this to be 110. So if this is 110, then here will be 70 degrees, because you know that opposite angles of a cyclic quadrilateral add up to 180 degrees. So after calculating this angle here, we can also get this angle. The whole of this angle here is 110 also, because first these are angles in a straight line, and you know this angle and this angle are angles in a straight line, and you know that angles in a straight line add up to 180 degrees. Or if you can also use that property that when one side of a cyclic quadrilateral is extended, the exterior angle produced will be equal to the opposite interior angle. So once we get here to be 110 degrees, here the whole of here will be 70 degrees. Okay, the same principle apply. This is a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral add up to 180 degrees. Or if you like, you can say that if one side of a cyclic quadrilateral is extended, the exterior angle produced will be equal to the opposite interior angle. That one will still apply. Now that we have this to be 70 degrees, and you know that the angle that we want is this one here. This is the angle that we want. So let us look at other properties still. This side you are given to be 30 degrees. And let us look at XWY. XWY, that this angle here is subtended by the same arc with this one. This one and this angle are subtended by the same arc or chord. And you know that angles subtended by the same arc to the circumference of the circle are equal. Okay, so that one will make this angle also to be 30 degrees. Okay, so once this angle is 30 degrees, and the whole of this angle here is 70 degrees, then this other angle here will be 40 degrees, and that one will make our answer there 40 degrees. Let's look at this example 2. In this example 2, we are supposed to calculate angle A, B, and C. How will you calculate angle A, B, and C? Let's first start by studying this diagram. In this diagram here, we have two circles, and these two circles intersect each other. That means that they are meeting each other. This circle is having a center O, and at this center O there is an angle that we've been given, which is this 150 degrees. In this other circle, we have circle center at R, and this R here we've also been given another angle, which is 120 degrees. So those two angles that we have been given are supposed to aid us towards getting the angles that we don't have, that is angle A, B, and C. So how will we calculate those angles given those two angles? So let's start by calculating this angle. This angle we can find. That angle will be 30 degrees because these ones are angles at a straight line, and angles at a straight line add up to 180 degrees. So if we've been given this one to be 150 degrees, to get here we'll take 150 minus 180 minus 30 180 minus 150, to get this 30 degrees. Also we can get this angle using the same rule. We'll take 180 subtract 120, we'll get there to be 60 degrees. So if we have this to be 30 degrees and here to be 60 degrees, that means angle A, B, and C we can get, because ROQ is a triangle, and interior angles of a triangle add up to 180 degrees. So angle ABC, angle A, B, and C will be equal to 180 minus 90. 180 minus 90. 180 minus 90 will be 90. That means if you take A plus B plus C, you'll get 90 degrees. So the whole of this is 90 degrees. So let's look at this. This is the center of the circle. If this is the center of the circle, that means OT and OQ are equal. And if they are equal, the triangle TOQ will be an isosceles triangle. And you know that base angles of an isosceles triangle are equal. If we've been given this to be isosceles triangle, this angle and this angle here will be equal. That means to get this angle here, this angle at T here, we'll take 180 minus 30. We'll get 150. Then that 150 is for the two angles. So to get one, we divide it by 2, because base angles of an isosceles triangle are equal. So here you'll have 75 degrees. This angle will be 75 degrees, and A plus B will also be 75 degrees. So A plus B is equal to 75 degrees. So if we have this ABC to be 90 degrees, A plus B plus C to be 90 degrees, and A plus B is 75 degrees, that means we can get this angle C. We'll just take 90 degrees, we subtract 75 degrees. If we subtract that, what will we get? We will get 15 degrees. So this angle C here is 15 degrees. I'm trying to look for a black pen. The black pen here. So this angle here C is 15 degrees. So angle C is equal to 15 degrees. Now let's look at this. R is also the center of this other circle. If R is the center of this other circle, that will make RS and RQ equal because all of them are the radius of a circle. So if they are equal, RSQ will be an isosceles triangle. And if RSQ is an isosceles triangle, that means that we can get this angle here, because this one and this one are now the base angles of an isosceles triangle, and they are equal. So C plus B will be equal to this angle at S. So where will we get this angle at S? We'll take 180 minus 60, then that one will get 120. 120 will be this angle at S plus this angle A plus angle B plus C. Sorry. So we'll take that 120, we divide by 2. We'll get 60. So this angle at S is 60 degrees, and angle B plus C, angle B plus C is this also equal to 60 degrees. Angle B plus C is equal to 60 degrees. This angle B plus C is 60 degrees. So if angle B plus C is 60 degrees, and we got angle C to be 15 degrees, what will be angle B? What will be angle B? Angle B will be 60 minus 15. Angle B will be 45 degrees. So this angle B here is 45 degrees. How will we calculate angle A? What is angle A? Angle A will now be angle A plus B plus C is equal to 90, and you have this, so we want to use this to equate. Is equal to 90 degrees, and we don't know A. We are given B here. You already got 45 degrees, and C we got 15 degrees. So take 45 plus 15, you'll get 60. So A plus 60 degrees will be 90 degrees. So angle A will be equal to 90 degrees minus 60, which is 30 degrees. here you have 60, here you have 36, here you have 80. So let's say 60 plus 36, 60 plus 36 will be 60 plus 36 equal to, that is 96. So take 180 minus 96. You get 87. Angle here will be 84 degrees. What angle here will be 84 degrees because interior angles of a triangle add up to 180 degrees. Interior angles of a triangle add up to 180 degrees. So once you get this angle, you can get this angle. Opposite angles of a cyclic quadrilateral add up to 180 degrees. So take this angle, subtract from 180. What will you get? 6. So this angle